guys, today we are going to be graphing lines. There are different techniques to graph a line. Today we are going to focus on graphing how to graph a line by finding ordered pair solutions. But before we do, let's go ahead review a little bit cool things about the XY plane. Okay, so we have our plane or flat surface, and it's cut into 4 regions, which are known as quadrants. The horizontal axis has a special name, that is our x-axis, and the vertical axis has a special name, that is called our y-axis. In order for us to graph these lines, we need to find some ordered pair solutions. But the question is, what is an ordered pair? So an ordered pair is written in the form XY. We say ordered pair because we got 2 things. Ordered because the order matters. The first number that you see, let me just say 1, 2. Okay, the first number that you see corresponds to the x value or x coordinate. The second value that you see corresponds to the y value or y coordinate. The question is, what is the graph of an ordered pair? The graph of an ordered pair is a point. Okay, you graph it however you gotta graph it. Okay, now what is the graph of an equation? Well, the graph of an equation is a line. Some of the lines may point up, some of the lines may point down, some of the lines may be horizontal, and some of the lines may be vertical. We'll just do the math and we'll see which of the 4 cases we have. Okay, so before we do our first problem, let's go ahead and look at standard form. There are different ways to write an equation. Today we're going to focus on standard form. So an equation is said to be in standard form if it looks like this: ax plus by equals c. In English, you want x and y on one side, constant on the other. The variables in here are x and y, and a, b, c are just numbers. Some equations may have both x and y. Some equations may only have the x variable. Some equations may have only the y variable. And I think that's enough of that. Okay, let's go ahead and look at our fun problem. So for this video, we are going to graph 3 equations and we're out. Okay, so it says graph the equations. I want to point out that it doesn't say what technique to use, so I'm just going to find ordered pair solutions. If my equation has both x and y variables, something that I like to do is solve for y. The question is, do you have to? No. But the thing is, me and fractions don't get along, and if I solve for y, hopefully it'll make it a little bit easier for me to pick nice values for x, so that way I can avoid having fractions, or I can make sure I have integer coefficients. Okay. That is too many words. Let's go ahead and do this. I'm not nervous. Okay, so let's go ahead and solve for y. So if you're not with the y, you gotta go to undo the x that's being added to our y term. Let's go ahead and subtract it, and that will give us 2y is equal to negative x plus 6. Now the question is it okay if we put 6 minus x? Yeah, it's totally fine. The reason why I recommend or why I put the x first is because this is going to lead into another technique that we're going to do later on in a bit. So x term, constant term, but you could put 6 if you need to. Alright, so our little love note says let's solve for y. So let's go ahead and isolate that y. To get rid of the times 2, let's go ahead and divide both sides by 2. Now the question is, can we use a long fraction bar on the right? You know what? You sure can. The reason why I don't recommend it is because students tend to make technical difficulties. When they do the long fraction bar, they'll only they cancel out the numbers, but they'll forget to divide it into the variable. But if you divide each term by 2 versus the long fraction bar, you will avoid that careless mistake. So we are going to write this. This is going to give us y equals, and you can write this however you like. You can leave it as negative x over 2, but I would prefer to highlight the coefficient. So let me insert my special effect 1. And instead of leaving it as negative x divided by 2, we're going to write it as fraction times x. Okay, so you'll thank me later, especially when we get to a later section. So we're going to write it as fraction times x, namely negative 1/2 times x, and then that will leave us with 3. Let me go ahead and highlight this. This is how I highlight. Again, I can't use pencil for the videos because the pencil doesn't project too well. But the reason why I highlight this with the bubblies is because if I make a mistake, I can just erase it. If I use an actual highlighter, I can't erase it. Okay. So now that we solve for y, let's go ahead and do an xy table. Okay, we call it xy table because we have a table with x and y values. So we can pick random values for x or random values for y. Let's go ahead pick random values for x, y, because we already have this solved for y. Okay, so you pick any value of x, any value of your liking. My favorite x value, if you can read my mind, is 0. Why? Because me and 0 get along great. Okay, so when x is 0, to find the value of y, you have a nice equation. It's -1/2 times x plus 3. So it's -1/2 times whatever x you chose plus 3. You and your mental math is great, so if you can just do it mentally, go for it. But if you're like me and you want to show your work, that's fine too. Product of -1/2 is 0. Product of -1/2 and 0 is 0, and that will leave us with 0 plus 3 or 3. So our first ordered pair solution is 0, 3. So let's go ahead locate it in our graph paper. I forgot to put xy. Okay, so how do we graph these points? So gentle reminder, so we're going to start at the origin, so where the x and y axis meet. Then we're going to apply the x value, and then we're going to apply the y value. I mean the x coordinate and then the y coordinate. So the x coordinate is 0, so that means we're going to go 0 units to nowhere. Okay, x is 0, so we're not going to go anywhere side to side. Y is 3, so we're going to go up 3 units. 1, 2, 3. Yeah, I have to count out loud. Cool. So we need 2 points to do a line, so let's go ahead pick another value. So the question is, do we have to pick the same x values? Absolutely not. Okay, so it doesn't matter which x values we pick. If our arithmetic is correct, when we put our line up our graphs together, our line should match. Okay, so my next favorite x value is typically 1, but in this case I don't want to pick 1 for x because -1/2 times 1 is going to give me a fraction. We don't have time for that. So what I will recommend, I will pick multiples of 2. Okay, so whatever 2 will cross cancel into. Okay, so in this case, multiples of 2, 2, 4, 6, 8, and their opposites, -2, -4, -6, -8. So if x is 2, let's see what y gives us. So we have -1/2 times whatever x value we chose. So like the question that I get, how do we know which x value to pick? This is just whatever you want. Just make sure it fits in here. If you want to pick x equals 57, go for it, knock yourself out, but stick with smaller numbers. Okay, so coming back, when x is 2, what is the value of y? So to find y, it's -1/2 times the x we chose plus 3. Okay, punch it in or freehand it, it's up to you. Quotient of 2 in itself is 1, so that will leave us with -1 plus 3, which is 2. So in this case, when x is 2, y is also 2. So let's go ahead graph that. So from the origin, x is 2, so we're going to go 2 units to the right. Y is also 2, so we're going to go 2 units up. Okay, we just need 2 points to draw a line. If you're an overachiever and you really want to check your answer, you will do a 3rd point, and if all 3 line up, then you know you nailed it. Okay, but in this case, I trust us. Okay, so let's do this. So we take our straight edge. I kindly ask students, let me go ahead and move this. Okay, I kindly ask students if they use a ruler or straight edge. You don't need a ruler because you're not measuring anything. Usually I use my plastic book marker because it's smaller, but I lost it. Okay, cool. That's it. Make sure you use a ruler or straight edge. Put arrows at both ends to let the reader know that the line goes forever in each direction, and you're good. Okay, you know your math. Please don't get dinged on little technical difficulties. All right. Problem B. So how are we going to knock it out? Same way, solve for y, do an xy table, pick random values for x, and plug and chug. So I'm looking at problem B, and I'm like, okay, let's go ahead solve for y. But the problem is there's no y, so we can't use that technique. Some equations may have both x and y variables, and again, some equations may only have the x variable, some equation may only have the y variable. If there's no y, well, there's no y. Okay, so in this case, we're going to solve for the only variable that we see, namely x. It's like, oh, why do you write so many words? Because I love speaking to myself, like if I write down my thought process, I'm hoping that I will remember why I did what I did. Okay, so to solve for x, hopefully that's what I said. To solve for x, if you're not with the x term, you gotta go. Let's go ahead, subtract 14 from both sides, and that will give us 2x is equal to negative 12. For the grand finale, to get rid of the times 2, let's go ahead, divide both sides by 2, and that will give us x equals negative 6. Let me go ahead, highlight that. So in this case, let's go ahead, do our table of values. So now, bear in mind that unlike the previous equation, this equation doesn't have both x and y variables. So my thought process right here may be a little bit different. For me, I'm trying to pick random values of x. But for this equation requires that x always equals negative 6. So let me speak to myself. So x has to equal negative 6. Or you may hear me say, oh, it's locked in at negative 6. So in this case, I can't pick random values for x because x is locked in at negative 6. It has to equal negative 6. So what am I going to do? I'm going to pick random values for y. Okay, so my favorite y value, you guessed it, 0. So procedure says pick a number for y and then plug it in to solve for x. So when y equals 0, I substitute a 0 for y, but there's no y. And guess what? X is still negative 6. So that will give us negative 6 comma 0. So let's go ahead, graph this. So from the origin, x is negative 6, y is 0. Okay, so let's go 6 units to the left and then we stay put. Okay, so we have 1, 2, 3, 4, 5, and we just missed it. Okay, there's like a movie that says missed it by that much. I don't know, whatever. Okay, I'm nervous. Okay, so now this is the situation. We were just, I think, one tick mark, 1, 2, 3, 4, 5. We were just one tick mark shy, and I'm very tempted to just like estimate it or even extend this graph paper, but I'm okay when the line goes outside your graph paper because it's kind of hard to just stop the ruler right at the end. But the points you like explicitly graph, those needs to be in the actual graph paper, even if it's on the edge. So we're gonna go ahead, adjust the scale. I think we can just adjust it by 2. So 2, 4, 6. Yeah, we'll have space. So I'm gonna put a 2 on the right side. If you want to put negative 2 on the left side, that's fine. Now, just because we adjusted the scale on the x-axis, it doesn't mean that the scale on the y-axis also has to be adjusted. If you want it square, then also change it to 2. What else was I going to say? Oh, yeah. The only way the reader knows that you change the scale is if you like put it, okay? And if you do, please put it next to the axis. Don't put it like at the edge of the graph paper. All right, so with that being said, we're counting by 2. So negative 6 comma 0. So we're going to go 6 to the left, and then we're going to stay put y-wise. So we have negative 2, negative 4, negative 6. So we go 6 units to the left, and then we stay put because y is 0. We're not going to go any units up or down. All right, so 1 point down, 1 more point to go. So another random value for y, let's go ahead, pick 1. So procedure says substitute a 1 for y and then solve for x. So when y equals 1, there's no y, so x is still negative 6. So our next ordered pair solution is negative 6, 1. So we're going to go 6 units to the left and then 1 unit up. So we have 2, 4, 6, and then 1 unit up. Okay, so that will be negative 6, 1. We just need 2 points to do a line. We have 2. We're not overachievers, so we're not going to do a third one. Okay. Fantastic. All right, for the grand finale, because I said we're doing a total of 3. Okay, so this equation problem C also doesn't have both x and y variables, and I'm okay with that. I got over that initial shock. So at this point, we're going to solve for the only variable that we see, namely y. So we're going to say solve for y. Okay, so if you're not with the y, bye, you gotta go. So to undo the subtraction by 30, let's go ahead, add 30 to both sides, and that will leave us with That will leave us with 3y equals 24. Cool. To finish it off, to get rid of the times 3, let's go ahead, divide both sides by 3, and that will give us y equals 8. And let me go ahead, highlight it. The reason why I highlighted is because pretty much I need these equations to locate ordered pair solutions. Okay, solutions of the equation, and as a result, points that are on the line. Okay, so for our XY table, cool. So again, I am trained to pick random values for X, and in this case, the value for Y is locked in at 8. So let me put that a little love note. Why? What's so special about Y? It has to be 8. Has to equal 8. Okay, but it's okay, this doesn't affect my normal flow because again, I'm used to picking random values for X. Okay, so my favorite X value, remind me, it's 0. So procedure, substitute a 0 for X and then solve for Y. So when X equals 0, we plug it in, there's no X, and Y still equals 8. So our first ordered pair solution is 0, 8. So let's go ahead and graph it. So from the origin, X is 0, Y is 8. So from the origin, X is 0. So we're not going to go any units side to side. Y is 8. So we're going to go 8 units up. So we have 1, 2, 3, 4, 5. And we are 3 tick marks shy. So let's go ahead and adjust the scale. You can adjust it to whatever you want. 2, 4, 2, 3, 4, 5, 6, 7, 8, whatever. But I like counting by 2s because if I need an odd number, it's just right there. Okay, so let me see if I would have enough space if we count by 2. So if we count by 2, this is 2, 4, 6, 8. Yeah, we have enough space. So let me go ahead, put the tick mark. So I didn't put let me go ahead and label the scale by 2. We didn't adjust the x-axis, so the scale on the x-axis is still at 1. The scale on the y-axis is now 2. Okay, so let's do this. So we have 0, 8. So x is 0, so we're going to stay put. Y is 8, so we're going to go 8 units up. So we have 2, 4, 6, 8. And I'm just going to put an 8 here, just so I don't have to count again. Okay, as much. Another X value. So my favorite one is 1. So procedure, plug in a 1 for X and then solve for Y. So when X equals 1, there's no X, so Y still equals 8. So another solution of the equation is 1, 8. So that means that another point on this graph is 1, 8. So let's do this. From the origin, X is 1, Y is 8. So we're going to go 1 unit to the right and then 8 units up. So from the origin, 1 unit to the right and then 8 units up. Remember, we're counting by 2s. Fantastic. We have 2 points. That's all we need to do a line. If you're an overachiever, you want to do a third point, go for it. And if all 3 points line up, then we're good. Cool. So we are done graphing wise, but there's just something that I want to say just to add to our number sense. Okay, so number sense is just code for feeling comfortable with numbers. So things just to have in the back of your mind. If your equation has both x and y variables, it doesn't matter if the equation is in standard form or not. Okay, if your equation has both x and y variables, then the graph is gonna be slanted. If the equation only has the x variable, whether it's solved for x or not, if the equation only has the x variable, then you're gonna have a vertical line. If your equation only has the y variable, then you're gonna have a horizontal line. So that's I said that before I read this. Okay, so this is what we have right here. The graph of any equation of the form x equals x1 is a vertical line that intercepts the x-axis at x1. Okay, so what I want to say, let me go ahead and write what I just said. X only, vertical line. Y only, horizontal line. Okay, looking at problem B, we have established that we only have the x variable. So I'm like thinking x only. I'm like, oh, x only, vertical line. When you solve for x, you have x equals -6. So I'm like, x only, vertical line. And in this case, my vertical line has to go through -6 on the x-axis. So this was 2, 4, 6. This was -6, and that's our line right there. Okay, right here we have y equals 8. Y only horizontal line, and in this case our horizontal line should cut through +8 on the y-axis. So if you wanted to avoid the table, you locate 8 on the y-axis, and then you do your horizontal line right there. So that was just a little extra fun. Hopefully you understood what I was trying to say, and if not, you don't have to memorize anything. You can just do the table. The table will tell you if the graph will be slanted, vertical, or horizontal. Fantastic. Thank you.